Okay, so got the boogers hanging out my nose. You're gonna have to excuse them. You know, that kind of thing. Anyways, I've been thinking about some stuff. Stuff that might make people angry, or maybe have them pause and think. I'm not sure yet. I'm eating a salad I bought from the store because I can't get myself to make salad. It's a Caesar salad with a spoon. Salads are best with spoons. Specifically with chopped leaves. Forks don't do as well. Anyways, there's the angry part out of the way. Now, here's to give you pause and think stuff. Alright, let's say for instance, we take our cosmic microwave background, radiation. Alright, we know about it, it's pretty well studied, we believe it's a thing. And it's like, I do too. Okay, no shocker there. You know, but let's take the fact that we live sort of kind of in a little bubble, so to speak, in terms of our, you know, cosmological background area, you know, our little bubble of a, you know, galaxy and, you know, supercluster-ish kind of thing, which I know that sounds like, well, that's huge. How is that a little bubble? I'm like, well, it's a little bubble in terms of the size of the universe, for what it's worth. So, you know. Anyways, moving on. I was thinking about it, and I'm like, we haven't really measured outside of our, you know, solar system, or a little bit outside of it with, you know, the, I forget what they're called, but the things we sent outside of our solar system. I think it was Voyager and something else, but I can't remember off the top of my head. It's been a long time since I've heard their names, so you're going to have to excuse me on that one. But what I'll say, the hair, is that it's like, well, that's a decent size area, right? Until you realize that the size of the universe is really massive. And then we learned about, like, constructive and destructive light interference, which radio waves are a thing. Then we learned that, like, really large amounts of gravity can absolutely produce light. And then I go, well, if there's the right radiation going on around a supermassive black hole, the right kind of light comes around, or at the very least a compression of space-time as it's spinning, it ultimately could create a degree of radio wave that occur, or they should be higher, but then it's like, well, they're really far away, and we found out that these black holes existed well before we thought that they could previously exist. Okay, and then same thing with galaxies and other stars. Stars of which can absolutely constructively and destructively interfere with that radio wave signal. Is there a possibility, starting out here, that there's a lower wavelength than radio waves that got amplified towards us, and we're redshifting it? Or is it that it wasn't anything like that, and we're talking above a gamma ray, but we've accelerated so fast that it's shifted into the radio wave spectrum? That and the other elephant in the room of, just because we have one measurement, you know, kind of area, and we account for as much as we can, you know what I mean, for the celestial bodies and forms around us, but we don't really know if there is a very large degree, especially now with dark energy and dark matter, to gravitational lensing, acceleration, or interference, or interactions with a radio wave, electromagnetic radiation that could possibly increase or direct it more towards us. Although we see it from any and all directions, I mean, if we're talking about a really, really, really ridiculously large size, then that looks kind of like a singular point to that. It still looks directed that way. It's just not flowing off to another way. Now, granted, we see this other direction problem of time, so we can point our little telescopes anywhere, and then we start getting it to go backwards in time, you know, which is great. I mean, of course, that's a great contradictory point to what it is I'm saying, which is a whole other thing, because it's like, well, that could just be that it was amplifying that signal. It could have started very early on, that booger, you know, to our beginning, which is then the Big Bang, right? Is what we're trying to head towards, right? Except that doesn't really equate to the same type of thing that we think. We don't really know what the actual total cosmic microwave background really is. We can't know that. If they told me that they do, I would definitely call them out on that. We have a pretty good idea of what our local backyard gives us. That's about it. Which is a pretty big deal, but then we base our theories and assumptions off of the going backwards in time thing for the Big Bang. And, you know, that's not terrible, but then there's nothing stating at all that there isn't something else going on with that in such a way that we're just obscured from a longer distance of being able to see something. Which, you know, could mean that actually it turns out that those galaxies we think are primordial, but because our resolution and our, you know, ability to really see that much further, clearer, is not as good as it really could be, then it could start that problem again all over of, actually, it turns out it's just, that looks the same as anything else that we have around here right now. So we have not even gotten near what's actually that far out. And in fact, it destroys and it collects itself, and then it destroys and collects itself, all in a little, big, ginormous ocean of our absorbable universe. Like, it's small. It's not the whole picture in any aspect. And so then that means that we haven't even scratched the surface of the actual time of our universe so far. And the Big Bang suddenly becomes a little bit different. It could be an acceleratory event that's a big multitude of different things around us, or our little neck of the woods, that ultimately created a larger degree of acceleration during that point in time. And then we coalesced, quotation marks, I like it, precipitated out from our higher energy state down to where we are now, where things could solidify a little more and do chemical interactions and other atomic interactions, which is cool. I'm sure that they have thought about this. Like, there has to be a way to account for as much as we can, but it's the other problem of, like, yeah, but I would like to understand way further out what that distance, I mean, the radio wave, you know, background is in terms of that distance and changing, because we can't account for all of these little gravitational lensing and interference, destructive and constructive amplification energies, gravitational, blue shifting, amplification, and more from that far away. There's a lot of stuff there, and now that we have dark energy, dark matter, it starts becoming more and more fraught with difficulty to account for all of those given possibilities. Even supercomputers would be hard-pressed to really understand that for a very long time. Like, it'd be one hell of a calculation. Not to mention we don't have multiple detective areas, so like it turns into, well, we're hoping it's like this. We actually don't know. Like, see, that's the problem. Like, if I could go a few galaxies or superclusters away, and then kind of sort of get the right kind of angle or in the sort of plane of existence or something, which isn't really existence, but you see what I'm saying? Like, because sci-fi talk is we're in the same plane of existence. Meanwhile, me, it's inclination and all this other orbit stuff and bullshit like that. But it's still what it is, you know. But it also speaks to the fact that we really don't have an idea. We don't. We have a decent idea of what we have seen so far and what it could mean, logically speaking. That's about it. We have not gone that far away, you know, and so we're kind of throwing what we can together to explain what it is we see, because, of course, that's science, you know, explanations for what we see. I mean, I've talked about, like, different ways of detecting, not so much on my YouTube channel, although I suppose I can right now. I've talked out loud to myself about it. Possibly hackers, government, corporations, you know they're looking. Anyways, getting into it, it turns into like, well, actually, if we can entangle the right kind of thing, like a Bose-Einstein condensate. Let's just go with Bose-Einstein condensate. We're not entangling it. Nothing is entangled here. We'll go with super cold. We'll superposition it, and then we'll allow for a gravitational interaction to create ultimately a given momentum increase to drop it out of its superpositional state, which will give us a better detector for gravitational wave energy, especially if we can propagate more of them around the world. Not to mention, it can also give us a degree of understanding, if we get enough of them, if it curved or if it started, you know, and then it trails off, you know, that kind of thing, for how much gravitational fields interact and basically work similarly, possibly, to a pressure wave and a light wave. You know, kind of like a duality in its own self, whereas a field and a particle in an aspect, but it's not really a particle, you know what I mean? This one is more field than particle, which light's more particle than field, you know what I mean? So that could be a really interesting little endeavor. And then I've thought about like how to make fields in a much larger array. Fields being very operative, weird words, you know, for people that don't know much about that. You know, kind of like, what is a field? And it's like, I think really, really thin atmosphere. Yeah, I think really, really thin atmosphere, basically. And like some of them are a little bit more directed, and so they get like, you know, really curved, and they get more energy and interactive forces, like a magnetic or electromagnetic field. But they're caused by a pole alignment and spin, which is the kinetic force they're in, that is there, momentum, you know what I mean? That kind of thing, to a degree. They say it's not, but I go, yeah, except, like, you don't get any actual, like, anything going on if you don't have movement. You know, the whole absolute zero thing. So, you're both right and wrong at the same time, to me, quantumly speaking. So, there's that part. You know, but then it's also a frustrating thing, because I'm like, well, what are fields? How do I make fields, you know, get compressed? Quotation marks there. And it's like, I'm not trying to compress fields, am I? And it's like, well, no, you're trying to kajigger them the right way, which is a bad way to put them. It's like, I use the Futurama term because it's like, it makes sense. It's like you're just sort of like, but like you need to do it the right way. And so I ended up coming with this idea of a material that sits inside of and around a fluid, like a plasma, that creates a field differential, kind of like a capacitor. And they resonate, depending on the energy input, giving us entanglement. And now, we don't usually want entanglement for our telescopes. But then, if you do it the right way, you manage to create a very different type of telescope. That is, when when it drops down and you basically create a bunch of denoising areas, you can create a very specific resonance, harmonics, entanglement to very, very long radio wave lengths. That would be incredibly highly resolving and focused on these materials. That would allow for you to have the electricity dumpage, effectively, to then have as a detector that you could then program. Now, it's a bit rough for some people to maybe understand why the hell that might be anything at all, especially when it's like I have to use the right metamaterials, and it's like, well, they're not technically metamaterials, but then, they're compounds, arranged in the right way. We don't need to cool them off, which is great, which makes it a lot easier to use the plasma. It's really more eddy currents, electromagnetic and statics that align certain field focal lengths and denoise and capture the vast majority of other less wanted and desired wavelengths, because you can put it in a box or a sphere, more specifically, is what I was planning on. Then I'm able to have a 360-degree reduction. Which, why would you want that? Because there's neutrons. Neutrons can create a given degree of capacity to interfere with that. And they also happen to be weirdly enough interactive with certain fucking really powerful radio waves. So, now, that's kind of a fringe theory for some. But then I'm like, well, just in case. I mean, a sphere is a sphere, so what's the problem? It's pretty easy. I mean, I don't see what the issue is, really. I can just put a bunch of stuff behind it if you want to capture, and that'll reflect it, so I have a greater degree of captured, light. So it's like, I'm just throwing it out there. There's nothing saying I can't still get all those extra wavelengths from the rear. It's just, they're reflected, and if you don't know, reflected does not in any way mean they didn't lose energy, and they didn't ultimately become disorganized, and therefore harder to really utilize in that capacity as a telescope. So I don't really like that. That's kind of my issue with radio wave antennas. There's not as much energy there for what it's worth, depending on their source and their strength. Because radio waves can be quite powerful too, but they're very low. They're like weakly interacting particles, for a layman's term example, which I suppose wouldn't be very layman's term for most people. They don't interact much. They're very long. Which gravity could literally just be a very long, fucking, hugely, ridiculously long wavelength of light. I mean, give me a shot on that one. Is it that impossible? I mean, optical tweezers can happen, and we know pressure waves in a given medium can actually draw things towards us, if done appropriately. So, I don't know, it's like, is it that impossible that gravity is a version of that? I don't know. And then I was thinking about valves. Yes, before that. Specifically, I was thinking about Nolan Sykes and Donut Media. He has this old vehicle. He has a big old iron block V8. And it's like fucking terrible in terms of like its actual performance and volumetric efficiency. And then I was like, right, well, there's an easy enough way for old iron blocks to be made into something new, because I was thinking about high-low. There's a guy on there, I forget what his name is right now, but he's the other side, and Nolan's usually the guy that has to get the cheap components. And I'm like, well, porting is a big part of that. And then if you can get like a valve timer and buy valves, new valves, and then you can drill out the old valve area, seating area, and weld up and plug it up and then put in a angled valve, meaning change their valve angles and drill and then machine to the appropriate size for the right valves, meaning either oval or just a larger circle, total, because they usually have one valve. But it's like, well, larger is actually kind of better in terms of valves, because diameter means greater degrees of actual airflow, volumetric efficiency for the given design. So they have a very specific type of volumetric efficiency afforded to them because a 14-inch pizza, I forget where I heard that, Kyle Hill did it, but it's like a 14-inch pizza is like half the size of a 16-inch or something along those lines, because the outer edge, and then you take the surface area, and it's like equivalent to the same kind of size of a 14-inch or something like that. I forget which actual sizing that ultimately meant, but for me it turns into a similar design where it's like, well, there's a bunch of hog outable, meaning there's just a bunch of iron there that I can just grind the hell away, and I can reseat certain areas with like brass tubing or something like that. I can make a parabolic curve funnel where it's wider to a smaller size valve, increasing volumetric flow, speed really. But then I was like, well, wait, I can do you one better. For that valve to be angled, and then I can make a teardrop shape for the valve stem with a little bit of bumps and channels and grooves and waveguides, which is a fancy way of basically saying I grind a little bit in there, not much, small, and I have it on the tail end of the teardrop. You cut a little bit in there, a little wavy pattern, and then you flare out by like creating little notches, triangles that are there that create a lower pressure zone and a higher pressure zone, and that curve in air into the valve area. And then I was like, well, I'm wait a second. I was like, I'm going to put in some basic grooving, some wider to smaller, channeling on the bottom side with a little bit, it's a small amount, right next to where the valve is, and at the top. Okay, so it's like where that little circle is at the top. I'm going to create a degree of these stators that have little bumps and dimples, and they're going to have essentially all a stator is a kind of like a triangle, like a wing shape that's got like a little space in between them. And so what that does is it creates a little pocket where it'll create a bunched up high pressure zone and a lower pressure zone as I create these little dimples next to where the bottom side of that channeling grooving from wider to smaller is. And what it will do is it'll create a higher flow path, a lower reduction in terms of resistance. So there's resistance to flow, and when you do it appropriately, you create a much faster flow path that's wider to this smaller area, so it compresses a little bit. It's not really, it's just higher velocity, but then you kind of are compressing it by doing that. Well, if I on the valve stem have a nice parabolic curve, and I have a little seating area that's up at the top, it goes up to where those little channelings and dimples are. As it goes down, it'll skip off and over onto the parabolic curve, and then I can create little channeling from the kind of just straight angle and then kind of diffused off, kind of like what I did with the teardrop shape, channeling, and then the vortex inducers. Well, I kind of created a different version of a vortex inducer by having it channeled one direction, and then I have a slight curve at the very tip, but it's not going to go into where the actual seal area is on the valve. Instead, which even then, it's like, well, because it's a teardrop and then it's very, very directed, I can just sort of curve it in to where those little stator areas are anyways, and then they can match. They can be quite sealed at that point. They're not going to shift around, and then sodium filled, anyways, you probably want that. It's lighter with a little bit of ceramic coating, probably aluminum or something like that, to help dissipate that heat not have as much transfer. I tended to go like, well, if I just use a chromoly ceramic, meaning chromoly steel, and then it's ceramic on the outside, that's decent, thickness that really reduces a large amount of heat transfer, but then I also make it vacuum sealed on the inside, it's hollow. Then I'm able to get lightness and then hardness, but then stiffness, but the best part is lack of heat transfer, which is all really, really good stuff for a valve, for your intake, you know what I mean, a poppet size valve. Anyways, it would curve it off and it'd create a degree of vortexing down the cylinder as it skips off and fills up the cylinder, helping, hopefully, air-fuel mixtures, and therefore your burn, giving you more power, but also there's more air. You know what I mean? There's more air coming in because they're a larger diameter. And then I was like, well, the valve stem is going to be longer. And then there's a bucket now. We're going to do a bucket. Got to get the bucket out. So that way you can use your regular camshaft, and you already have timing anyways, and so you're going to have greater duration and greater lift. But now you can time it. So that way it's a little better for you for that low end. And you can even get some scavenging maybe at the top end. That would be good. And then I was thinking about the same thing with the exhaust, but instead of the lower, kind of like 45 or even lower angle, for like in that 20 something range for the intake, well, this one's going to be a little bit more of a vertical kind of 40, above 45, not above 50. I think 7 is probably the right call on that side. But then it's another version of the channeling on the roll. Actually, this one is a little different. So it's like the valve I had to channel and groove, and then same thing with the top part of where the exhaust is. So it's like, if you're talking about this, it's like, think about my fingers. It's like those are channels, those are little grooves. They're kind of like waveguides. And versus the rear. So it's like, it's only on one side. And the other side is just going to suck in. I got some channeling there that are wider, or smaller to wider. And then same thing at the top where it's just smaller to wider. But the reason why I'm going to do that is because it allows for a very specific pattern of airflow inlet. And I have to do a parabolic curve on the valve, again, along with that teardrop shape, towards the exhaust port, because it goes out more easily and it comes in more easily as a result of having higher pressure and then lower pressures on the valve, and then a better boundary layer effect that allows for it to flow easier. And then it goes to a lower pressure zone towards the exhaust, which is just going to be slightly larger than its standard. Like the intake is going to be larger, and then it'll go to a smaller version. So it's quite a wide, version of parabolic curve, but like you get a faster degree of airflow for naturally aspirated, because he probably doesn't want to do forced induction. And then I'm like, ram air intakes, they still exist. Ram air intakes, get a big old funnel, big old parabolic funnel, ram air intake, ram air, ram air. Anyways, besides the point though on that one, because the exhaust is really more about like, well, it's going to be wider where where the valve inlet is, and it's going to be smaller, but it's slightly. We're talking like a millimeter in terms of actual size. Like, you usually just want a straight pipe, but like the way it's designed on the inside, where it's smaller to wider, what it does is it creates a version of an equalization of pressure. But it also happens to make it more efficient by using the energy that is there to expand to help increase velocity and the given vacuuming effect for the scavenging for the exhaust for the given diameter size of the valve, which is good. That's a good way to do it, especially since it's like, well, they're huge, ginormous iron block fucking heads that are terrifyingly just filled with a bunch more iron than they would ever need. It's kind of stupid, actually, how much iron is actually there. And so, like, it's a decent way to get around some of the performance issues of these heads. And then I can make a basic, kind of ram air style intake from the hood, or, just off to the side, like two off to the side that are bifurcated, and then into one for the intake manifold with some velocity, meaning larger to the same size diameter for the ports. That way it increases velocity of flow and improvement of the volumetric efficiency, which is a big deal for engines wanting to make power. And the camshaft profile is still the same, but now it's like I get more lift and duration because I did, and then I also have more volumetric efficiency for air coming in, so I make more power because I can burn more fuel. And they're iron blocks anyway, so they can usually handle a little bit more. I just have to make sure the bottom end is not just a 3-piece. I can add the other 2s, so that way the crankshaft happens to be supported in 5 spots and get that girdle going. And there's going to need to be a slight change in the compression there. You know, so you're going to have to do like different timings for your, probably want to get out the trick distributor that changes its timings based upon an RPM and the, you know, carburetor as well, to allow for a higher degree of, you know, fuel to air mixing, unless you want to do port, which port's really easy for those old suckers. Just drill into like those little channeling fluid, because I mean, if he's gonna have to fabricate and all he has to do, I mean, he's gonna be fabricating, so it's like he's not allowed anything other than valves, sheet steel, a welder, and, you know, a valve timing upgrade, you know, for the serpentine belt or whatever it is that allows for that. And then it's like, well, that would still beat, you know, paying like the $10K that they would on high, because high-low means they get to spend a lot of money. It's a lot of high money, high cost, but hopefully it's worth it. Whereas this one, it's like, well, it's low, but you get to put a lot of labor into it. And so it's like, you got lathes, you're going to need to do the, you know, buying the really expensive, or just, you know, cheap enough and shaped the right way. Because it's like, well, I'm not going to do any of the channeling or fluiding for my porting or whatever, so now it's just like a parabolic funnel, you know, to that degree, and then I'll just shape the, you know, the intake for the ram air, you know, into that, and then, you know, have that kind of style. So it's a parabolic funnel, and then it's just a regular little parabolic curve for the valve sim, and maybe they can figure out a way to stick something onto it that allows for that, you know, little sleeving or something, you know, so that way the air is, you know, less, you know, obstructed, or teardrop shape, that kind of thing. So it'll get you really far. And same thing with the exhaust kind of style. It's like, well, as long as there's a parabolic there, and, you know, it goes from a little bit wider, but then slightly smaller, but then, you know, you don't really need to do that much to it on that side. You can get pretty far with that. You get a lot more performance for that old engine, and you still need to, you know, make sure that it's a 5 versus the 3. The 3 can still handle a lot. It's just higher degrees of torque means more movement for the block, which means that you end up having a issue with, you know, misalignment, and then you have piston slap on the cylinders, and then you'll have grooving and digging in the cylinder walls. And so that means you end up having to get around that by having the 5 side, which is really just drill and then weld and then machine, which is like, that's a lot. And it's like, well, so a lathe will work, or very specific types of sanding. Just yep, no, I'm gonna just get it to where it's the right size, it's the right area. You know what I mean? That's all you end up really kind of doing on that one. And you just kind of weld, plug it, and, you know, drill, plug, weld, tap, all that stuff, get it in there. Then it's like, well, it's gonna be better than if you didn't have it, but like, you know, a real machine shop probably is what you want. But then at the same time, it's like, you can probably get away with that. You can probably get away with that if you know what you're doing and you're good enough and competent enough, meaning like you've welded. You can probably do it. If you built an engine, you can probably do this, because all I'm talking about is drilling and carving out with a Dremel and that kind of thing for porting and grooving and stuff. So it's like the valves and the timing on the serpentine belt or whatever it ultimately is for those upgrades, like that's totally doable for him. And it's like, it will outperform that head that he will do, you know, in terms of aluminum. It's not gonna outperform its weight characteristics. For what it's worth, it won't. But like it's a larger diameter, it should ultimately have higher flow characteristic velocities and higher compression, therefore, as a result, alongside of a greater degree of any volumetric efficiency, so it can run at a higher RPM now with a greater lift duration and timing, which gives you a better, result for natural aspiration. So it's like a whole bunch of better, basically, but it's like it's low cost in terms of like it's cost and effort. Like you have to put a lot of effort into that. But at the same time, it's like if it's high versus low here, it would be like, oh yeah. Yeah, well, I mean, you spent that much money in terms of convenience and everything else, and it's like, this is a labor of love now, is what you're talking about, right? Like, this isn't going to be done in like a weekend. It was like, no, it can technically be done in a weekend. For what it's worth, it can be done in a weekend. You're not going to do anything else other than that, but you could do it in a weekend. Which no one ever fucking likes to hear that part. So it's like, yeah. So it's like probably like a 3-week to a month kind of ordeal. And like you plug away at it like every 3 days, like three days a week, that kind of thing. So, and give yourself 4 to 8 hours doing it. And then it's like, well, yeah, no, then you have that for all 8 of your cylinders. And it's just increasing valve size, but it's like you have to get the right angle, valve angle, which they already actually have all those tools, like on the market for what it is, for what it's worth. Like they do have that, and so that's where it's like, well, wait, what? And it's like, yeah. See, my whole thing and shtick was like I'm getting it all very close to being perfectly seated, with like. And then just making sure it rubs the right way by opening it and closing it. So that way it really seats. And then using a certain aggregate that then binds to the valve. That then makes a very rough mated surface, but it doesn't make it sealed in terms of like you can't move it anymore. It's just like it'll make sure it's really, really sealed. But it's a high temperature type of sealant aggregate, which they make those, but then it's like that's probably not what he's going to do, and like that's just to gain like super high hardcore efficiencies out of a vehicle, when it's like, well, you don't really have to do that to get like it's 70 to 80%, upwards of what it is I'm thinking about. Like you just need a parabolic funnel and like the valve size increase and all that stuff, because what I'm doing also is it's like, oh right, as the onrush of air, it has a pocket to dissipate with the vortex area that it induces in that little stator area, and then like same thing with the little dimpling, and it keeps rotating around in that little area inside the pocket of the port. As it still will rush somewhat out, it tends to trap itself a little bit more inside the port, and then it slowly comes out. And hopefully you're at the right RPM where like it's not going to be that big of a deal. You know what I mean? And so you get a higher degree of pressure in your cylinder. You also happen to have that also work as a air fuel mixture if you have a carburetor, or a little bit of leftover gas from port injection. And so it'll clean it off a little bit over time. You're still gonna have to probably get in there every so often and clean them out with a fucking toothbrush. Especially the exhaust, although it's small to large, so instead of stators or any of that, it's just straight out. Anyways, I was thinking about it because it was like, well, that's an easy little trick to gain efficiencies out of like older vehicles in their heads if you know what you're doing. You know what I mean? Like you don't need to do much. You just need to know enough to be able to make valve angling, larger size valves, and a better flow path for your valves, which is porting. That's all you're going to do. And if it happens to have 5, spots for the crankshaft to be cradled in, then it's like, well, then you don't need to do any of that, and that's out the window. And then you just got to make sure you're probably cast iron, everything is at that point is able to handle your pressures, which they probably will be able to. And so then it's just making the timing work for you, and then tuning it. You gotta tune it, get the right jet size, gotta have the right airflow kind of thing for that jet size. So the intake manifold, it's a little bit tuned a little differently for that sort of style. And then timing, because timing becomes a big part of your ignition timing, either before or after top dead center, depending on your version of how it is you want to run, with either increased compression or lower compression versions. Because forced induction will ultimately create a version where you can create from that top dead center, and then the slight offset as it changes, that's your new top dead center. And so you start at top dead center, and then you have that effectively create its version of expansion, and then you get your torque from there. So that way you don't have an overpressure, you don't blow your heads off. This is a good deal. It's a good way to go about making it so that way higher compression ratios are not going to cause you problems with those kinds of things. Although he'd be naturally aspirated with like a ram air, most likely, at most, if that. So I really doubt he'd have to worry about it. But it was just a way to think about it, because it's like, I still really care about this guy's car, and I want to see his valve work go up against some other guy that's like, I have an old car, well, I could just, buy these inline 4 or whatever banger styles of or V8 style, aluminum heads. And I'm like, or I could do a little bit of work, and I could show off all of that and be very educational to all these people for porting and valve change and redesign, because like all that's doable. I mean, that's machine work if he doesn't want to do it, because I'm not sure if that's more expensive or cheaper, because it's like, well, that's $5,000, probably for aluminum heads or something like that for a V8. And so it's like, well, if that's what it's going to cost, like how much does it cost to really have someone just do some valve, angling changes and, give you some new valves and, timing on it with some buckets and a valve stem length increase? How much more is that really in terms of expense? And, tell them that, like, I want a larger to a smaller, that kind of thing. And it's like, well, I could probably get that. It's the weight problem. That's usually the worst part. Like, weight is a huge deal for anyone that's trying to make power. But it's like, that's the thing. It's like high-low. It's like, well, in terms of a performance increase for the low cost that would be that, then it's like, well, actually, especially if you do it yourself, that's comparable to better. You know what I mean? That's comparable to better. For what it's worth, it would be comparable to better. It's just going to weigh more. It's all about the size and diameter of those pistons and those valves. And so, there's a version of like, well, how far can you really go? You can't really add more valves to those heads, but you can always make them bigger. You know what I mean? And so, for me, it's like, I was just thinking about it because I like the idea of turning something old into something new by changing some things around. Like I was thinking also about this idea I've had for this thing that we do with cylinders. Okay, so cylinders happen to have this problem of expansion and contraction under either high load or low load and off, you know what I mean? And so I was thinking about spring styles of ceramics that could be coated on the inside of the cylinder that happen to have a harder cylinder coating, powder coating at this point, for the inside of the cylinder. Same thing with valves. So that way there's less heat transfer, less likely knock, and then it's less friction happy, and so as a result I gain an advantage of efficiency, transfer of energy to my vehicles, bottom end, result of wheels. Anyways, that's what I was thinking about. I was like, well, powder coating is something that we could do, and then you just have to bake it, you know what I mean, for what it's worth. Like, that's all you have to do. And then I was like, well, there's multiple ways of baking something. You know what I mean? I don't just have to use an oven. No one says I just always have to use an oven. There's nothing saying I have to just always use an oven. So then it turned into, well, if I can make the cylinder essentially sealed enough, and then heat that cylinder up by having, a coil of any kind that I heat up, electromagnetic resistant, or not electro, but electrical resistant coil, then there's nothing saying I can't basically bake it from the inside of the cylinder instead of having to have the entire block, so long as the block on the outside is warm enough. And so that turned into a bunch of mirrors. I was like, well, a bunch of mirrors pointed at this fucker, and a fucking little sealed environment, because that's all it is ceramic, with the right kind of mirrors pointed at it, and then having electrical resistive heating coils inside of the powder coating area. Then it's like, well, that means I now suddenly have a powder coat that's been heat treated, and it can slowly cool it off, and I use a lot less energy as a result. So there's nothing saying I can't do that, especially when it's like, well, there's argon that exists. There's this stuff called argon, so there's nothing saying I can't just fill that thing with argon. So that way it's less reactive to the oxygen in our atmosphere, or nitrogen. And there's nitrogen, but it's like I probably just use argon and then just, compress it back into a cylinder and then reuse it, you know what I mean? So there's nothing saying I can't do that. And then it's like, well, I baked the powder coat inside of my cylinders with a spring ceramic, which is like, what is a spring ceramic? It's like, well, a spring ceramic, that's exactly what it says. It's a ceramic that, is kind of like spring steel. It's bendy. You can bend it. That's kind of a thing. And so it's like, oh, yeah, no, and a hardened ceramic that's like a lot less heat conductive and has a large degree of reduction in friction exists. Like, we already know about a lot of those. It's just a fuck ton of them. But, that's kind of what that is. So it's like, take your pick for powder coating. And, those are kind of expensive, but then, yeah, are they? You know what I mean? I could do that. I mean, I only need, so much for, powder coating the inside of my engine cylinders, and the top part of my or the bottom part of my heads, and the same thing with the top part of the piston skirts. I just need to make sure that they're close enough. The gap tolerance is good, and so that turns into its own version of, well, yeah, I still probably could do it. You know what I mean? I'd have to bore it a little bit and hone it. Then, it's like, well, this is the gap being, and then it's like, well, I can still bore and hone the cylinder afterwards. It's about the size of that spring steel and the layering. So it's like, or not spring steel, but the spring, ceramic and the hardened ceramic. So it's like that layering there, that you have to apply the spring, and then you have to bake that, and then you have to do the harden. You know what I mean? So it's it's an involved process, but then it's like, well, it's doable though. And I gain a large advantage, a very large advantage. For what it's worth, it's like I would gain a lot less heat, soak into the cylinder, which is also really great with a lot less friction, which is a really, really big deal, which then gains me a massive advantage over a regular style car. I still have, oil. I still have oil, but I also gain an advantage, a pretty decent chunk advantage. And now that's going to cost you a lot less than having to go to a person to try and make it for you. You know what I mean? And so it's like, well, that's going to be on high and low, in a version, right? It's like, oh yeah, no, I could do that. I could do that. I could do that. There's nothing saying I can't do that. There's nothing saying I can't do that. Why can't I do that? Why can't I do that? Why can't I do that? There's nothing saying I can't do that. As long as the gap tolerance is good, I don't see why I can't do that. Piston rings? Yeah, piston rings are sucky. I hate them. Every time. They're the most frictional, happy components of the entire... I suppose I could still try and do the powder coating. I don't know it would really do any difference, really. But, it's what it is. You have to still get the right piston cap, but it's like, well, it's a reduction of friction, so it's worth it. And it's just powder coating and baking it and all that. So, that it'd be doable. But, I don't know. It's like... Yeah, that it's the exhaust manifold to the 4-into-1, which I usually do 4-into-1. We're talking about V8 here, so I'm always all equaling tube header into one guy. That is literally what I love. But I do a weirdism. If you don't know what a weirdism is, it's like, well, I have a extruded aluminum or, well, steel more specifically, that typically has a vacuum sealing, because that's not impossible to do. It's like, if you're willing to fabricate, there's nothing saying I can't put a tube around a tube. And multiple sections, and then just put a nipple on there and suck it out with the right kind of valve. And then it's like, well, now it's vacuum sealed. It's singular, but it's vacuum sealed. It's like, I got a vacuum sealing, which is good. And I can put the powder coating on the inside of that ceramic. There's nothing saying I can't do that. I just need it to be even enough, you know. And then it turns into like, well, then I have a weirdism for the shape, the geometric shape. So it's like, from the port, it's actually larger on the inside of the diameter, but it's only because it has channeling, larger channeling, or smaller channeling to larger channeling, that then just go off to a regular smooth surface that are on the inside. So it's like, why would I do that? And it's like, it improves volumetric efficiency flow. It makes it a larger diameter that it goes off into, and so it makes it have lower pressure there. But it also improves its flow rate as a result of that, because it has a boundary layer area that's there that it tends to stick around, and then the inside part, which is smaller, happens to flow more easily and readily through that channeled area, thus reducing boundary layer inefficiencies. And then it gets sucked later anyways by the time it leaves the end of the valve into the 6, you know, or 4-into-1 or 6-into-1, whatever it is, you know, type of area, which improves its efficiency, which is just a little simple weirdism trick. But it's like, how do you get that? Where do you gotta get out the old Dremel tool. Gotta get that old Dremel tool, unfortunately. But then it was like also thinking, well, if I go from that area, if it's going to curve and I need it to curve appropriately, then I need a wider diameter pipe there. And so I tend to make that curved area a wider diameter pipe that has, again, those little grooves on the inside with little bumps and dimples around that. And then the other side, it's just kind of flat. It's kind of raised with like a parabolic, you know, area there. So it bifurcates and it creates a slight degree of pressure in that area, and then that'll make it so it flows a little easier because it's wider in that area as well, and so it happens to create a degree of curvature for the equaling tube header. And that's just fabrication work, which is like, you say that like it's so easy, but it's not, because fabrication work sucks. And it's like, no, it doesn't. It doesn't suck. It doesn't. No, it doesn't suck. No. It's really fun. Actually, for certain people, it really is actually quite fun. But it's one of those things where it's like, basically, it allows for, as it goes back to the standard size diameter of piping, a much greater degree of efficiency of flow rate for the exhaust. Then that heads off into a, you know, into one, so 4-into-1 area. And I tend to combine those 4 into like those little, you know, kind of like your fingers here, where it's sort of like really close together. And then they have little grooves in there, so that way they flow and then diffuse more easily as they are bifurcated with teardrop shapes into like one singular little wider. Because for all math people out there, and any car or gearheads, those size ports for those exhaust tubes need to be added up or multiplied, depending on how you decide to do it, and then given it one length or one size slightly bigger than that. Not one whole tube bigger, just slightly bigger. And so you take, like, let's say it was 33 millimeters in total, you know, for that size. Well, you're going to do 34. And the reason why you do that is because it allows for that expansion to create another vacuuming effect. And as long as you happen to have a small, and I mean small, and it doesn't even have to technically be from smaller to larger, although I do that, in terms of these grooves on the inside of that area, it allows for that to be sucked out, and then anything that's inside of the tubes, the rest of the tubes, also flows with it. It improves its flow characteristic velocities, but it's very low back pressure now. It's just very high flow rate. Like, there's very low back pressure for what it is. It's a much different type of design that's prioritizing higher RPMs and higher speeds of air pumping than a very high torque system, which still produces a decent amount of torque so long as the bend allows for that pressure wave to come back to a degree, which is kind of like a two-stroke to some level. Okay, now then that goes into one. You get your whatever shrinkage from that smaller, that small till it's slightly larger, and then back to smaller for your turbo. If you happen to have a forced induction, that's where the grooves that go from wider, they go into combining into one single flat, smooth surface area that is the inside diameter size the same as the one in the as the turbo inlet. Then I groove slightly into that. I go from wider to smaller. Like, that's the transition point. I do wider to smaller, and then I don't do anything. It's very short. We're talking like a quarter to a half inch, and then it's that in length, and then it's a quarter or less, an eighth of an inch to even smaller. So a quarter to an eighth would be just fine, and it's ringed around that, and all it does is it laminar flows it a little bit and allows for the speeding up of that air and compression slightly, as it allows for it to expand in a certain area, and then it goes and recombines, and that pressure wave will then add in to the rest of the turbo air inlet, just a little bit slightly behind. It just improves its flow characteristics, but also improves a degree of its pressure wave characteristics into it. It's not much, but every little bit can count when you're talking about very, very high RPM and extracting, like, well, I want to get a little bit more than 5 horsepower. So it's like, all right, I'll do you one better. If I do all of these valve things and I do all the stuff, well, it's like, no, I'm doing probably 150 horsepower for you easily. You know what I mean? But let's say I didn't do any of the valve work. I just did the exhaust, and that was it. Okay. Well, this makes it a lot more free flowing, and I probably freed up about 10 horsepower. And then I gave you an exhaust that goes into a turbo. So then that gives you the increased degree of efficiency for that turbo. And let's say it was maybe 10% of that, maybe 10% efficient turbo. So I got 1 real percent out of it. But it doesn't change that 1% means a great deal when it comes down to the RPMs when it kicks in. So instead of 35, I got 33. 33 is felt. 33 is felt. Okay, and so when you're talking about, like, let's say a V8, and you do all the little tips and tricks that I'm talking about, then it comes down to all of these different massive changes for valves and intake and all this. I'm going to push a large amount of much faster flow rate air that is higher compression, more fuel, and therefore more power to that turbo, because it's going to be 8 into 1, but I usually just tend to do 2 of the same size, so that way they're just straight backed, because that's easy into 1 catalytic converter, because then that's pretty easy, because it's a way cheaper design. And you still get really, really good characteristics, because I can make 2 small or medium-sized turbos act as a much larger turbo. I still have a air-to-air intercooler, but the thing is I combine both of these typically into one that goes into the air-to-air, and then I'll have that be a wider to a smaller than you think sized air manifold, intake manifold. So let's say it was like 5 inches coming out of the air-to-air. Well, when you divide the port size and really the valve size, the valve diameter size, so you take all 8 of those, you divide it, or multiply it, and then you have to go from this 5 into like what's the actual diameter size of that. And what I found was it's irrelevant. It's airflow. Okay, so like you're gonna have to understand that the cylinder down to the valve area is a pressure cylinder. It's like an air scuba tank. Okay, that's all it is. It's a pressure cylinder. So it's like if you can feed it enough, then it will remain at that pressure. And so that turns it into, this 5 is actually going to be much larger, and then I'm going to divide it into bigger, and then that goes into the port size smaller, which then goes into that. And so like that turned into a big cylinder, so 5 into a much larger, which actually improves volumetric efficiency characteristics, because it has a lower degree of resistance to traveling into after it's already been compressed or condensed, depending on your version of thermodynamics classes, because it cooled. And so that's condensed is what they say, but it's still compressing it because there's still pressure. So whatever, never my problem. Anyways, it turns into, well, this then can fill it up really rather rapidly at a lower volume because there's less pressure. Although it's technically denser, there's higher volume. Of course, that's all a matter of perspective at that point in terms of thermodynamics. And so I tend to go, well, it's a smaller volume because there's less pressure, even though in reality-wise, it's more volume, it's more dense. But it's a larger volume that then can remain at a higher degree of efficiency at a higher degree of top-end pressure that then is flowed much more readily and has a chamber resonance that turns a much higher resonance frequency to a much lower resonance frequency, which then gets constructively interfered with as it flows downwards into being a push and then a put, like a slap force, like a put it down, you know what I mean, kind of force. So you get a push and a slap, which is actually really good because that helps push through those cylinder pressures sometimes that aren't really technically there, but it's more of it rushes in and then it hits it, and then it needs to still, as the cylinder is traveling down, continue filling it without having that pressure wave oscillate back out. And so that push tends to resonate with inside those parabolics to a degree. Again, it's not a perfect, I'm going to completely remove any of it. I'm not looking for that. I'm looking for it to just be very efficient getting in there. And so that's basically all I'm going to do. And that's why I was thinking about Nolan Sykes' vehicle and his engine, because I was like, well, that engine has a lot more to give, and it's just not there. And if I were to do it right, all I need is the right amount of mirrors. All I need is the right amount of, just like refractory bricks that they use for blacksmithing, and the right electromagnetic or electrical resistive coil, because that's IR heat into the cylinder with a little bit of argon, and that'll give me everything I'm looking for. That gives me, with the right layering and the right, making sure that I properly hone and bore it back to the right size, which is just some drill tools at that point, getting it to the right sort of length, or diameter, inside diameter sizes, then the gapping is fine. And I've gained a massive increase in advantage in terms of torque and overall horsepower performance, because all I need is the either distributor, or I'd just go with a basic bare bones ECU that would just tune it a little bit better. You know what I mean? Like that's basically all I would do. I'd get some coil packs and some tuning, some basic tunings, or I have injectors. I'd probably use two. I'd use a smaller and a larger, and then fire them depending on the given RPM at different lengths and different pressures, to be able to better manage my fuel input. But they usually don't tend to prefer that or like that, so they usually go like, just give me 2 smaller or medium ones. And it's like, right, I'll give you 3 smaller ones. That's a lot that could fail. So what if I just decided, hear me out, I gave you way too large of a carburetor, small jets, and then I put a small/medium sized port injector, and then I allowed for you to tune it, which is like overkill to a large degree. But it's like, I only need to pulse it the right way. That's all I'm looking for. I'm only looking to pulse it the right way. It's like, I have my bottom end just fine. You know, at that point, it's like, I've got bottom end just fine. Which is bottom end RPM, low RPM. Idle is just fine now. Now I'm going to have higher end RPM because I can fire it before the valve opens. And I still have all that extra air that I can flow through. And then I can still match the correct performance of air-fuel ratios. I just need to account for these jet sizes and this cylinder area, and blah, 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 blah. Individual carburetor, which I hate. I'm never going to do, truthfully, if I'm honest. But it's like, that's why it's like, this is a cylinder to a bunch, it's like a freaking bug. And it's like, yeah, actually, honestly, it's going to look a little bit like that. Except there's 8, so it's more like a spider. So there's that. And it's like, well, yeah, no, but it's like, I want to be safe about it. And it's like, yeah, well, and so individual carburetors are still doable. I'd make them larger than I should for each individual cylinder, and then stick that inside of the bigger cylinder on top of that. So that way, like, any of that pressure kind of gets captured by carburetors. That helps reduce some of the velocity stack problems that they usually end up having, as flow rates can change at different RPMs and engine speeds and barometric pressures. It gets contained a lot more easily, and then it's like, well, I have fucking, this is stupid. It's like, each one of those cylinders at, let's say it was 7,000 RPM, all right, would probably net you in the near area of like 500 to 1,000 CFM, easily. And they're advertising it like this CFM, and it's like, that's low. I need to hit way higher actual, like, airflow characteristics for each one of these cylinders. Like, each one of these cylinders for this diameter and this pressure at this speed will give me these flow characteristics, which will give me this CFM, which will give me this kind of increase over what that can perform for just one cylinder. So it's like one cylinder per each one of those. It's like, I need to hit a certain CFM. I need a certain size that's going to make it worthwhile at the top end and at the low end for each one of those cylinders. So I can either do one per each bank, or my mind, it's one per each cylinder, because like that makes total sense. It's like, well, I'm just going to make it slightly more than that, and then I'm good. I don't need to be under. I just need to be slightly more. Slightly more gives me that flexibility if I want to add something, but more specifically for me, it turns it into, there's no restriction. No restriction means I don't have to worry about it. And it's really just the multiple throttle body cables that you end up having to run through all of that. That kind of thing. Not to mention the distributor. You have to have the right trick distributor, because you probably wouldn't go with coil packs. But if you're willing to go with coil packs, then it's like, right, well, you have an ECU and you have the, you know what I mean? It's like really small jets for each one of those. Like, you don't need to be like going hard on that. And so you're really going to try and eat the fuel that you've got coming in, but it's more about the flow characteristics at that top end. So it's like the bottom will be just fine. You know what I mean? I got timing I've got all the things, you know what I mean? I just upgraded this engine to basically better than any modern day off the line. I mean, this is a supercar, hypercar engine at that point, because it's like, well, I've got the ceramics, I've got the super large valves, I got them angled valves, you know what I mean? I've got the better porting and exhaust. I've got a really good exhaust, a really good intake. I've got, like, effectively a way more volumetrically efficient engine. And it's an old-ass iron block V8 from Nolan's like, just beat just the fucking wind out of the way, I suppose, with pure power at that point. It's like, 4-stroke this sucker up. Let's go for way too much. That's way too much, honestly, for what it's worth. But I bet you he still has, like, the ability to make it a 4, or, I mean, a 5, and if it's not already a 5, you know, crankshaft. And it's one of those things where it's more of a natural aspirated, and it's not a power performance increase. At most, he was probably getting, like, 75, maybe 100 horsepower, if that. You know what I mean? So, it's like, well, no, you are for sure going to be doing at least the 400. Like, depending on what you're going to really put for it in terms of, you know, fuel and overall air, if you want to do a ram air or forced induction. So you're going to go with my forced induction, then it's like, with all that exhaust and manifold work and everything, it's like, well, no, yeah, no, 400's easy. 400's super easy. I could probably get higher than 450 if I'm being really honest. So then it turns into, well, we probably don't want to do all that, but it's like, are you sure? This is high versus low. You're going to pay a lot less for just, but you got to learn how to fabricate and you got to do all that. But you do get a lot more performance than that person that's going to do a high tune characteristics and all these other things that he has to buy off the line out of catalogs, which, no offense to the catalog people, they do very good work and they work very well. But then that's the version between custom and off the line. You know what I mean? So it's like, well, this is custom work, and this will destroy the hell out of any high team advantage in terms of outright performance. Like, oh yeah, no, they think they're fast. Yeah, it's like, you're breaking all of my freaking transmissions, my axles. I need better really better brakes. Yeah, you're gonna need better brakes for sure, and a way better transmission. That 4-speed, that 4-speed's probably not gonna do it for you. I mean, are you drag stripping, or are you gonna actually use it for, like, I don't know, going around town and stuff? Because then it turns into, well, you're probably gonna want a 6 to 7-speed. You know, that's kind of what that is. So, yeah, and then it turns into, well, you can't really make that yourself, so you're going to have to buy that. You know what I mean? So it's like, well, for what it turns into for me, it's like porting, bigger valves, valve angling, and a better intake manifold and exhaust manifold would be, with the valve timing and better valve, the better valves would be the way I would go with it for the low side, just for natural aspiration, and skip the powder coating and all that. And then it's like, right, now I have definitely in that 300 horsepower range. You know what I mean? At the top end, you're gonna have that. Like, you don't need necessarily anything more than, like, the proper carburetor setup. You're still probably going to have to hit each individual carburetor area. So you probably have to do a bank-style carburetor, where you have a big cylinder above that then goes off into the cylinder below that happens to be going towards the either 2 or 4 pack of, cylinders that you're trying to hit for the carburetors that you're going to use. With a distributor, which definitely needs to advance and or retard timing, depending on your, preference. With a jetting change, you need to be able to change the jets by having them, as a higher RPM comes in, change it so that way they get a little bit, larger, a bit more fuel, which they have those. They already probably have those automatically, but yeah, that's one of those things where it's like, you're going to need that, because, like, otherwise, tuning this will probably be kind of annoying, and you still need the intake manifold where it's kind of like velocity stacks. So like those cylinder areas go from those larger, which is a parabolic curve, larger diameter to a smaller diameter, which is going to need to be the size of your ports, which are still larger to the smaller, which is a parabolic curve, which you're looking for. So a big old, really fast, but still kind of ramming the air in as it comes in. It also happens to get that bank of, let's say it was 2 or 4, that pressure wave, depending on how you happen to run that intake manifold into that pressure wave is going to oscillate over and be ready for the other cylinder that's going to fire. And so you'll do those banks of 2s or 4s depending on the firing order of your cylinders. And so you connect those to your carburetors. Those carburetors will only run for those 2 or 4 cylinders, so that way the oscillation pressure wave heads to the opposite side of the V8 to give it its increased performance in terms of pressure wave dynamics, especially at those higher RPMs. And then it still has a big bucket of air for it to effectively suck in a huge Flenham volume, more or less, which is a cylinder, which will then have your intake on both the rear and the front, which will be the square style filters, most likely, because you probably don't have circle style filters. But if you do have circle style filters, then do that, because like that would be good enough, truthfully. Yeah, so it's like that'll be good enough. Like you just need them to be the right, size and shape, because that cylinder needs to be fairly large for what it's worth. You know what I mean? And like that whole larger to smaller sized intake manifold, parabolic curve, it's like, well, there's a reason why I'm adding those cylinders like that. There's a very specific reason that it can't be super long. They can't be very long. They have to be short to fit all of this underneath a hood. And so, like, it doesn't matter where the intake is in terms of front or rear, so long as it's cut off. Well, I have it in both sides, so it's a bigger plenum volume, but it's also one of those things where it's like, it doesn't matter where you have the air that you separate from the engine bay coming in for those front and rear intake areas. It can be near the windshield, that's just fine. It can be near the front, it's just fine. So long as it is fresh air that is definitely insulated. You want it to be insulated and separated from your engine bay, because that's hot stuff and you don't want it to get in. Alright? So, as long as you do that, you're good. Because that will give you a better increase in performance for your engine. A solid 30 horsepower at their top end. Like, for what it's worth, it's pretty characteristic of most cold air intakes at top ends when you've separated it appropriately and you have a larger degree of intake velocity coming in as a result. Especially with the given oscillative pressure of the, combination of the different carburetor setup with your intake manifold that you have to basically probably fabricate out of aluminum, that you're going to weld, or steel, sheet steel that you're going to weld together, bend and weld and make sure you get the right curving and flaring out so you get a better parabolic curve. And then you combine it to your little, reservoir chamber cylinder that will then focus it into either the other opposite end or the same. Because it's one of those, well, you can do per each bank 2 cylinders, but then that's not how all firing, in fact, most firing orders don't really do that. So you usually have to do diagonal, which is usually what they tend to do. If you ever notice the intake manifolds that they have, they usually do X's. And there's a reason why they do X's, because a lot of them happen to have X cross pattern cylinders, but you need to separate. This is the big caveat. If you don't separate that cylinder from those other 2, then you don't get the benefit as much, which is why you have so many carburetors that you have to add in. And that's also why I have port injectors, because it's like, well, screw the carburetor thing. No offense to carburetors, I like them, but I don't like fucking around with them too much. It's like, make the jets a certain size, I have a certain amount of, given fuel, and then I can always add in the right amount of fuel as air intake velocities increase, and ultimately a greater volumetric efficiency is starting to be achieved at those higher end RPMs. And so I can always add in a little bit more fuel and timing to make that work. And so that's an easier way to get the right air-fuel ratio than trying to really get into the right jetting and carburetor setup, which becomes a bit rough after a certain point to make work. So it's a catch-22, because it's like you can do that. It's really just steel that you bend the right way and you weld. If I'm being really honest, that's all that is. You don't really need to insulate it, but then insulating it is a good idea for what it's worth, and then that's just putting another set of sheet steel that's bent well enough, that's around it, that's welded well enough that you can then stick the right nipple on and suck out the air, which is now a vacuum insulated piece. It's vacuum insulated. That's how vacuum insulation works. It just needs to hold the vacuum. But that's all it's doing, and that's good enough. And if you ran it for a really long time, of course it'd start to warm up, but it's always going to be colder than if you didn't have it. So that's what it is. Then it's the carburetor setup, which is really what the whole firing order problem becomes. Yeah, because a typical standard carburetor is like, oh, I can flow this well. And it's like, you don't flow that well to me. For what it's worth, you don't flow that well. And for a single cylinder at very top end, high performance, RPMs, it's like, you're not flowing well enough. You're not hitting enough air. And so if you're talking 2 cylinders, then that's fine. 2 cylinders, you can probably get a big ass carburetor and make that work. But you then also have 4 carburetors, which we've seen it before. You can do it still. It's 4 carburetors though, but they're now going to be different. They're going to be the cheaper kind that is going to flow really well, has very high volumetric efficiency, but I don't need to hit them with the same level of technical performance, because now the valves are going to really do the work for us, along with the porting, because it's the port injection and the porting that's there. And so I can run a lower jetting on the carbs, and that allows for me to gain the performance that I'm looking for. I still have to have fuel rails and all that, but that allows for that top end to really breathe a lot better, and that bottom end to still breathe very, very well. So they're just going to be cheaper. They're not going to be the super cool Holley carbs that have the double, opening thing, and you don't get that, unfortunately. So, it's more about timing. That's the tuning. Yeah, the tuning, it turns into timing. It's kind of like a Valvetronics, where it's like, or we're going to open up the throttle, but then the timing is going to be retarded at these RPMs. You know what I mean? So, well, not the ignition. It's going to be the, timing for the valves is going to be, changed, so that way you get less overall air coming in. So that way you still get your low end, bottom end performance that you're looking for. And then you can tune it accordingly from there, which is really what the main expense is probably going to be. But then you get massively increased performance from let's say he was getting 100. Well, he's going to probably hit that 300 to 400 mark still. But it's probably going to be when he's also heading, because you also have to do the cold air intake, and then that's going to be kind of like a ram air. You know what I mean? And so that gives you a increased performance at that very, very top end, ramming that air in. But if you didn't do that, it was just cold, it's off to the sides. Let's say it was just off to the sides. So you have 4 little spots on both sides, or 2 on both sides. So you have 4 spots that sucked it into your little, cold air intake, round, cone kind of thing that went into that sort of cylinder. All right, that's good. You can totally do that. That's really a good idea. You can always add scoops, though. See what I mean? It's so fast Like, it's like, you can always add scoops. There's nothing saying I can't add scoops. There's nothing saying, in fact, how hard would that be to add scoops? I mean, that's all that's going to be. I just need to offset them slightly. That's really, I mean, like, that could be a little lower, that could be a little higher. And then I've got scoops from a larger to a smaller area. I mean, that's all that is. And it's like, so you can do the ram air. There's nothing saying you can't do the ram air. See how fast it turns into the brain thing there? For, like, most people. It's like most people then go like, well, how hard is it to, I mean, I fabricated, like, I can bend some sheet metal and weld it, and then I can sand it. I mean, it's, you know what I mean? I can paint over that, as long as it's good enough, right? Yeah. There's nothing saying I can't do that. And it's like, there is nothing. And I would do it. In every way I would do it, truthfully. So there's that. It's the vacuum insulated part where you have to connect that. There's little lines to it. It's like you don't want a gasket to that. Which is really just, you know, gasket material for any, probably like, you know, HVAC system, high temperature HVAC system. You know what I mean? Where like it allows for it to seal up to the hood, because like it's an old car that has the little flanges on the, so it opens up like that, like little gull wings at the front for the hood. And so that allows for you to have those two spots on the side and still seal up to it and not have it be too terrible in terms of its performance, and still have a ram air up to certain points of, it depends on how you bend that, how you connect it. Yeah, it's like, well, there's nothing saying I can't do that, though. Yeah, right, back to the actual matter at hand. There's nothing saying I can't do any of that. But it's like, oh, that's cold air intake. And it's like, that's more air, and then that means you can have more fuel. And so it's like that top end at very high speeds is going to be very, very significant. Because you'll have a lot more pressure afforded to you. And so you have to tune for that. But it's like, you don't usually get a tune like that. You know what I mean? It's like, oh, let me just get out my blowers over here. Just get a big old fan. I'll put the funnel in there and just blow it onto that area. Oh, what's the speed? 100 miles an hour wind. Oh. Okay, thanks you. It's good. All right, thank you. But for sure, I wouldn't put it underneath 300. Like, for that kind of system, I wouldn't put it underneath 300. Because it's like you have larger valves, better valve timing, better volumetric efficiency for those valves because they're angled valves. And then they have longer duration and larger lift. And then you have a individual oscillative effect, meaning pressure wave effect, that goes to each individual firing order cylinder, which then also allows for that to be added into each individual cylinder to increase its ram air kind of style. And then you have the ram air, which effectively, if you're going to go that far, might as well, you know. And then you have a better volumetric efficiency of exhaust as well, because I talked about that. Yeah, and so that gives you a rather significant increase in terms of outright performance. Yeah, I can easily see 300 getting there. Like, that's not impossible at that point. Like, it's probably 300 be on the low end, and you know what I mean. Like, because you also have the timing and the tuning that's going to happen as a result of that. Because you're going to do it right, and you're not just going to do it and then, like, never actually get it tuned. So then it's like, well, no, yeah, you know, 300 easy. Like, it's really what the top end really will give you at the right speed. It's like, what is it? My mind says, you know, when it comes down to the volumetric flow and efficiency and compression ratio and air-fuel mixing and RPM. Because at that point, it's like, what's the actual RPM that you can hit? Because there's nothing saying you can't get a better crankshaft that has better, you know, balancing characteristics. But it's like, you're probably not going to do that. But then you can get it shaved and balanced, which you can do. It's like, if you're already going to go in there and change your valves and your heads, there's nothing saying you cannot get it balanced. You can balance a crankshaft a lot better to the heads that you have. Or, I'm sorry, the pistons, the connecting rods and the piston heads. you know, which will give you better performance by far. That one's a little bit expensive, but it's like it's shaving it and then rotating it with like an electric motor pretty fast, and then seeing, you know, what for the balancing that they have that service. So it's like, you know, knife edging it, yeah, kind of like that. You do that, yeah, because it's a big old cast iron crankshaft that has a lot of like weight that can be kind of cut out to a degree. You know, it's more about like shaping it the right way and reducing some of the weight, you know, and still remaining very strong. So, because I mean, that crankshaft's probably fine. The connecting rods probably are not fine at that point. Like, for what it's worth, like, they were never intended to run at anywhere near 300 horsepower. Nor were the wrist pins or those piston heads. But they're cast iron, but they're not forged. So it's like, I'd probably change it. For what it's worth, I'd probably change the connecting rods and piston heads. You know, at that point. Yeah, it's like I can still keep that crankshaft. That crankshaft's good all day. I just machine it down, you know, knife edge it, balance it, yeah. And then say, well, I'm already here, so how hard is it to really add in that ceramicing myself? You know what I mean? Like, really, realistically, how hard is that? Am I going to, though? It's like, yeah, I don't know. Point is, I could easily see 300. Like, you probably don't need to balance it, you know, for what it's worth. Like, you can probably get just fine, because balancing is a higher RPM. If you want to get a higher RPM, then you're going to balance that. That's what that is. Yeah. So it's like, well, you're probably going to hit around that 65 to 7,000. That's what you're going to do. You know what I mean? Like, it was probably never going to go above that, for what it's worth. But now you have a lot more to give for that given RPM range. So, I would say I would get near that 320, maybe 350 mark. Yeah, I probably wouldn't get in further than that, because it's like, again, it's a 2-to-1 with it's a large cat, you know, and then like that's going to give you your single pipe exhaust that you can do with like a high flow resonator or hybrid flow through. And that'll probably give you all that you're looking for when it comes down to that. Yeah. And it's like fairly cheap, because you're going to fabricate it. You're going to fabricate all of those little parts yourself. Because like, you got a lathe, you got a bender, you got bending tools. You can weld. It's going to be a lot of work, but you can do it. But it will be fun work, because you'll see every step of the way the improvements. Just getting the carburetor and intake manifold, just that, not even changing valves, would literally change the game. From like, I might get 100 to I'm getting 100 plus probably. You know what I mean? Yeah. And then it's like, right. And then it's like, right, well, the valving, do I need to do that? It was like, well, you know, let's try and look at this exhaust. So let's look at that exhaust. We'll do the exhaust. And it's like, wow, yeah, no, I'm definitely for sure 100 plus. You know what I mean? Right. And it's like, then you get your tuning going, your distributor and everything, and your carburetors and your port injectors. And it's like, right. Yeah, no, and I'm going to see that now really give me those results. Like, that's just in the 150, you know, maybe 175. Then it turns into the bucket and valve angle and larger diameter valves. It's like, that's when it's like, well, this is big boy stuff. I'm a little afraid. You know what I mean? I'm not gonna lie. I'm a little afraid. Like, for what it's worth, you're gonna be a little afraid. You're gonna have to machine, you have to drill, you have to port. You have to do all that. I have to weld. Yep. Worth it though. It's like, well, I know how to make a parabolic curve. I know what that looks like. You know what I mean? I know how to get angled valves. Like, I can buy those. You know what I mean? I can get that parabolic curve on that. You know, no problem. I know what to look for on that. Like, those are the good valve stems. They have the little parabolic curve right there. The little, you know, little thing that goes to the valve flat side. You know what I mean? And that's going to be okay. In fact, I can fabricate that myself. There's nothing saying I can't do that. If they don't have one, I can always put that there. Yeah. Yeah. And that'll help with flow characteristics. So it's like, I'm going to make it a larger diameter, I'm going to change the angle. It's like, that's the scary stuff for some people. Like, I'm gonna have to get out the lathe. You know, I'm gonna have to stick this into the lathe, into a chuck. I'm gonna have to, like, get that right size of diameter, or I'm gonna have to get out the drill and then sand it. You know, then drill underneath, one size down, and then I'm gonna have to slowly sand it or get close to it, and then try and get it to the right size by honing it and then getting the right angle for the valve seating. You know what I mean? And it's like, all right, but I'm gonna do that on these things that I found, because that's practice. That's practice, and that's the thing I'm actually going to use. So practicing. Each one of those things is going to be practice. So I'm going to get better and better, and then I'm going to try on the actual thing, and it's like, now I've got these two heads. Now I'm going to try it. Now I'm going to do this. Is it working? And it's like, oh yeah, no. No, yeah, oh, is it working? Oh, is it working? It's like, there's nothing saying I can't get, like, one of those kits that allows me to change the timing. You know, do the serpentine belt timing or something like that. If they have that, they've got to have something like that, you know, for valve timing for older vehicles. Yeah, got to have it. Right. And so it turns into, well, now I've got timing, valve duration, valve lift, a larger valve, better flow. Volumetric efficiency went way up. So that's already like 100 horsepower is what a lot of people may not understand. Like, that's everything I just stated is like 100 horsepower kind of thing when you combine them all together. To me, not to everyone, but to me it is, because it makes sense. It's like, well, you know, if you make sure to do it the right, porting and yeah, it's a bigger valve, a much bigger valve. Oh yeah, holy shit, is it a bigger? It is angled so that it flows a lot better into it. Yeah, and the timing, so I can get scavenging at the top end. Yeah, scavenging's effect gonna be a big deal. I have fuel and air taken care of, and exhaust taken care of. Yeah, that's 100 horsepower. Yeah, but it's probably a little more, because then you also have the volumetric efficiency increase. Before, it was very not volumetrically efficient. Yeah, and that turned into, well, that volumetric efficiency might have gotten you to 175, you know, with all the little, you know, things, exhaust and intake. You know what I mean? That's all you got. Well, now I've got a much more volumetrically efficient. It's not just valve size. It's not just that they are angled. It's also that it's working in conjunction with those intake and exhausts for those higher ends, with the oscillation effect, with the given parabolic curve that is allowed from the intake manifold to the port into your intake, alongside of a slight parabolicing for the exhaust, which gives you a reduction in back pressure and an increase in back pressure to a degree. Right, because it's a slightly wider to smaller design, which improves its flow, but it also means there's lower pressure out right where the valve is, but there's a slightly higher pressure where the port is, which will then be reduced as it goes into the intake manifold, as it goes into a larger volume, creating a reduction in back pressure. But that oscillation still goes there, so you still get that torque, and you still have the scavenging. So the volumetric efficiency improved again. Yep. And so it's like, well, let's say, you know, volumetric efficiency of 60%. Well, I'm getting closer now to that 100% mark. You know, 93, 97, 99, something like that. You know, something like that. Which means at top end it flows a lot better, which gives you a better air-fuel mixture, ultimately combustion, and ultimately power and torque and efficiency. Yeah. So then it's like, well, 100 horsepower, just valve size. Not getting into angling and volumetric efficiencies. No, just valve size and some lift and duration. Well, now I improved its volumetric efficiency, so it's like, well, right. So that alone would give you what? An extra 50 to maybe 100 on that. Depending greatly on airspeed and fuel used and timing and a whole bunch of tuning characteristics that, you know, have to get involved into that. So then it turns into, okay, so what would it be? And it's like, that's why I'm like, it's around that 300. I would definitely put that in that 300 category. I'd probably put it closer to a little 300 plus for sure. No questions asked. I wouldn't even look at that dyno as if it was wrong. But that's because I know about all the things that are going on to make that engine run like that. You know, that's the point I think about, because it's like, that's a massive improvement. That's a massive improvement. Like, let's say it was 75, well, now we're at 300 plus. Let's just go with 100. Well, then that's times 3, right? It's like, well, yeah. That's a 3 times improvement. 3 times improvement. That's volumetric efficiency, compression, air fuel, spark, all of that. And that's all within the standard RPM range of that engine and what it should be able to do. That's why improvements are such a big deal. But of course, you're hitting the bottom end, or not the bottom end, the top end. Like you're basically diminishing returns at that point. There's no real going above that without getting into really trick systems to improve all of the efficiencies enough to the point where it actually makes such a significant bump that you gain something from it. That's where, like, the stators I was talking about, that's where I was talking about with, like, forced induction. That's why I was talking about, like, the oscillating, you know, kind of chamber design. There's a lot more efficiencies to be gained and had, but that's also the ceramics to be improved upon inside the cylinder and the top of the cylinder head for the headers, and then balancing crankshafts and the connecting rods and everything else. I know, I hear, I don't see anyone over there, so you know, but there you go. Bye.